Hello everybody and welcome back to MrMiers Math Channel. Today in Chapter 7 we're talking about Section 7.5, which is talking about inverse functions. Alright, so what we're going to do is find inverse of linear and nonlinear functions. Alright, so let's get into it. So first, we use inverse functions all the time without realizing it. Now, we might not be actually finding the inverse function or verifying that something is an inverse function, but we do use them all the time. They're built into computer systems and things like that. One simple example is, when you're trying to Google a measurement, like, how many kilometers is 2 miles? That's something that's just a simple inverse function. And then obviously miles to kilometers and kilometers to miles, those would be two inverse functions. All right, so we've got a bunch of different uses of inverse functions, and let's talk about what an inverse function or inverse relationship actually is. In section 2.1, you learned that a relation is a pairing of input and output values. For a given relation, an inverse relation switches the input and output values. So if we have our original relation, that matches these inputs to those outputs, like -2 to -4. The inverse is just going to match those outputs to the inputs. Okay, that output value of the original relation is going to become the input value, and then the input value becomes the output value. Essentially, it just returns what you plugged in. Okay. What we're actually going to do is find inverse functions first. So I kind of reordered some of the slides just because I want to talk about this first, and then we're going to go back to the previous examples. So you're going to see the numbering is a little off, and that's just because I didn't want to change the numbering because it wouldn't then match up with the notes that have been sent out. All right, so to find an inverse function, first what we're going to do is replace f of x with y. Okay, and then after that, we're going to switch x and y and solve for y. So basically what we're doing here is rewriting it in equation form, and then we're switching the input and output values. Okay, so y becomes x becomes y, and then we're just going to solve for y like we normally would. All right, so we would subtract 4 from both sides, divide by 2, and what we get is x minus 4 all on 2. All right, so this function would be, or this equation would be the inverse of that previous equation. All right, so simple steps: replace f of x with y if it's written in that form of function notation, and then switch x and y and solve for y. Pretty simple there. So we're going to find the inverse of each one of these functions. So first step, once again, replace f of x with y. So we're just rewriting it. All right, and then after that, we're going to switch x and y, so the inputs become the outputs become the inputs, and then solve for y. So we're going to add 7, divide by -4, and we get negative x plus 7 on 4. Pretty simple. All right, last one. So y equals 3/4 x plus 6. Switch the inputs and outputs. And now solve for y. So subtract 6. So we have x minus 6 equals 3/4 y. And then we want to get rid of that 3/4. Remember, in order to do that, we don't want to divide by 3/4. We don't want to divide by a fraction. So what we're going to do is multiply by the reciprocal. So we have 4/3 times the quantity x minus 6. Awesome sauce. All right, so that's pretty simple and easy, how to find the inverse of a function. All right, and now we're going to go back here and get to examples 1 and 2. And in this, what we're going to do is verify whether what we have are two inverse functions. Okay, so functions f and g are inverse functions if f of g of x equals x and g of f of x equals x. So essentially, the output value, or the output function that we plug in, has to return the input value for each one of these. If they both return, if this composition both returns the original input value, then they are inverses of one another. All right, inverses can be defined as, you know, f inverse, which is read as f inverse. Okay, it's got that -1 there. It's not f to the negative first power. It's f inverse. All right, so we could show that f of g of x equals x and g of f of x equals x by plugging one function into the other. Let's demonstrate this on the next example here. All right, so we have two functions, and we're trying to figure out, are these things inverses? So first, I'm going to just write f of g of x, and then next, over here, I'm going to write g of f of x, and hopefully I gave myself enough space. All right, so for f of g of x, we're taking function g, and we're plugging it in to the input value of function f. So we're taking this whole thing right there and plugging it in to x. Okay, so that means we're going to just rewrite this equation, 3 times the quantity, this whole thing. Remember, we're getting rid of x here, and we're replacing it with this. The quantity 1/3 x plus 5/3 minus 5. Okay, and now what we're going to do is just simplify. All right, so it's 3 times this whole quantity. That's going to get rid of that denominator of 3, so we're just going to be left with x plus 5. And then we have x plus 5 minus 5. Plus 5 minus 5 would cancel out, and that does just return the input value of x. And then we have g of f of x. So in this one, I'm just going to erase this here. We're going to take function f, and now we're going to plug that into function g. So we're taking this whole thing right here, and then we're going to put it right there in this equation. So we have 1/3 times the quantity 3x minus 5 plus 5/3. Now 1/3 times 3x would just be x. 1/3 times -5 would be -5/3. And then we have -5/3 plus 5/3, which is going to cancel out. So since they both return that original input, when we do both of those compositions, they are indeed inverse functions of one another. Awesome. I know it's a long process, but really what should happen is we should have just like a bunch of undoing operations here, like 3 and divided by 3, you know, adding 5 and subtracting 5. Things, hopefully, if they're inverse functions, are going to cancel out. All right. Now let's move on to one that's a little bit more complicated, or at least appears to be a little bit more complicated. Okay, first f of g of x, we're going to take g, which is this whole thing, and we're going to plug it in right there. So now I'm going to rewrite this, 2 times this whole thing, the cubed root of x minus 5 all on 2, raised to the 3rd power plus 5. Now when we're simplifying, first thing that I'm looking at right here is our exponent. That's going to cancel out a radical. So then it's really just 2 times this part, x minus 5 all on 2. And then 2 divided by 2 cancels out. -5 plus 5 cancels out. And we just return x. Awesome. So it works in this case so far. Now we're going to take a look at g of f of x. So we're taking function f, and we're plugging it right there. So we're going to rewrite function g as the cubed root of 2x cubed plus 5 minus 5 all on 2. Now right here, I'm looking inside this radical, and we see that plus 5 minus 5, so simplify it a little bit there. So we have 2x cubed on 2 inside that radical, and then 2 divided by 2 would cancel out. So we have the cubed root of x cubed, which is just x. So once again, yes. All right, these two things are inverse functions. Awesome. What happens if we're given a graph? All right, if we're given a graph, we can see that they're inverse functions because they'll be mirrored about the line y equals x. So y equals x will be that line of reflection, all right, and they'll be the same distance, and remember when I'm saying distance, I mean perpendicular across that line of reflection. They'll be the same distance from that line, okay, each one of these values. All right, so let's check it out. Maybe we just want to determine whether something is a function or not. From previous sections, we could use the vertical line test. That's used to determine if a relation is a function. And using that idea on the previous slide, that we could find the inverse by reflecting it about y equals x. If we reflect a vertical line, okay, so some vertical line here, across the line y equals x, what we would get, oops, there we go, is a horizontal line. All right, so the horizontal line test will allow us to determine whether the inverse is a function. All right, so vertical line test to determine if the original relation is a function, and then horizontal line test to determine if the inverse is a function. Okay, pretty simple there. We want to run a horizontal line throughout this whole graph, and if it ever intersects more than once, then it's not a function. In this case, any horizontal line running through this graph is going to intersect just once. Okay, we can tell right here, right away, that a horizontal line is going to intersect more than one time, which means that inverse is not a function. All right. All right, so in the next one, we're just going to determine if this is a function, if that inverse is a function, and then we're going to find the inverse. So as we're running that horizontal line throughout this graph, we can see that the inverse is a function, and now since it's a function, we're going to find the inverse. So we're going to write, don't want yellow there. There we go. Y equals x cubed plus 1. Now we're going to switch the inputs and the outputs. So the output becomes the input becomes the output, and then solve for y. So subtract 1. Take the cubed root. So we get y equals the cubed root of x minus 1. So if the inverse is not a function, we don't have to do any of this. We can just say no. All right, so notice that in this one, we're determining whether the inverse is a function just on this parameter alone, that x is greater than or equal to 0. All right, so that's our restriction. So just on that part alone, yeah, this inverse is a function. So now let's find the inverse. So y equals x squared. Switch the inputs and the outputs. Take the square root. And we get y equals the square root of x. All right, and if we graph something like that, very rough sketch there, we get something that is symmetrical about the line y equals x. Awesome, last one. Once again, this, if we use the horizontal line test, we can see that this is going to be a function. Even right here, notice, like obviously, looks like it's a straight line right here. Okay, but that's just because this picture is pixelated very highly. So there is only one intersection point right there. Okay, if we would zoom in on that graph, we could see that this is still a curve here. Okay, so now we're going to find that inverse. So y equals 1/7 x cubed minus 3. Let's switch the inputs and the outputs. Now we're going to add 3. Multiply by 7. I'm just going to write it as 7 times the quantity x plus 3. And then take the cubed root. So the cubed root of 7 times the quantity x plus 3. Of course, we could write 7x plus 21, but I'm going to leave it in that factored form. All right, folks, that's it. If you enjoyed this or found this helpful, like, subscribe, and share. Thank you, and have a great day.